Hi friends, this video we are going to solve the minimization problem using simplex method. So first of all, the minimize problem we will convert into the maximize problem. So simply we multiply our objective function in terms of minus, it will give the maximization problem. So our problem become maximization of minus z equal to minus 2 times x1 plus 3 times x2. So this is the subject to the constraints are same only, okay, same subject to constraint. X1 plus x2 less than or equal to 4, x1 minus x2 is less than or equal to 6, and all the decision variables are non-negative. So we are going to use the simplex method. The first step of simplex method is I want to represent all the terms are the equation symbol. So our constraint is I will take as x1 plus x2 plus slack variable s1 equal to 4, x1 minus x2 plus s2 equal to 6. So now then our objective function I can represent as minus z plus 2 times x1 minus 3 times x2 plus 0 times s1 plus 0 times s2 equal to 0. That way we will convert. Our aim is maximize the minus z. Now I want to form the, so here the constraint have the only 2 equations but 4 unknowns. So 2 equations, 4 unknown. So from that one we will make it that 2 are the basic variable, that is I took from the simplex method table says that initial basic feasible solutions are always S1, S2 is the basic feasible solution. So first I want to make the table, that is first of all table basic, and here z, and the variable x1, x2, s1, s2. The right hand side will take as a solution. So similarly here I can represent basic variables are ez, s1 and s2. So ez coefficients, what is the coefficient in this one? The objective function is, that is a 0, so minus 1 plus 2 minus 3 0 0, my right hand side also 0. The first equation coefficients are, there is no ez in part of, so that's why 0. Here we get as 1, here we get 1, 1, 0, 4. Second is there is no 0, there is no ez, so that's why 0, 1, minus 1, 0, 1, 6. So this is the initial simplex table. This is the initial basic table. Now what is my aim is, I want to increase the, here minus z. So here minus z, here also minus z. Okay. So now our aim is, I want to make an the s1, s2 are the basic variable. So I want to increase x1, x2, then only my z value will increase. So among that I want to choose what is the largest negative value in the 0th row. This is 0th row, that otherwise we call it as a R0. So from that we take minus 3 is the maximum value. So that is the new entering variable. Next is some variable going to remove from the basic variable, correct? So S1, S2 will be there. I want to choose this one. So I will take this column. It is 1 minus 1. So 4 divided by 1 is, that is called ratio. 4, that is minus 6. So whenever minus 6 we don't want to consider. So we will take S1 as the new non-basic variable. Okay. So X2 is new basic variable. S1 is new non-basic variable. So that meaning is I want to say that this guy is the pivot position. This is my pivot. So what is the pivot? The Gauss elimination method, what will take? The pivot position only 1, remaining that column, all other elements are 0. So using this fact, we will make it as this guy is already 1. So first of all, I want to represent the new table, I want to make it. Then basic minus Z, X1, X2, S1, S2, the right hand side, that is called solution column. Here we take the basic is minus Z, S1 and S2. So clearly this is already is 1. So first column I write it as it is. So 0, 1, 1, 1, 0, 4. So I want to represent this guy might be 0. So what I can write it as R0 is R0 plus 3 times R1. That one only it makes the 0 is possible. So what is the meaning? 0 times, so you will get minus 1 here. 3 plus 2 is, you will get it as here 5. Here you will get 0. Here you will get 3. Here you will get same 0. Here already 0 is there. 3 times 4 is 12. Next is I want to make this element is 0. So how I can make? R2 is R2 plus R1. So that implies this guy is become 0. This is become 1 plus 1 is you get 2. This is you get 0. This is 1. This is 1. This is 10. So this is X2. This is our table. This is the first iteration table. Now you look here in the 0th column, nothing is negative. Okay, so you don't consider about the minus Z, only this guy, the basic variable. The X1, X2, S1, their coefficients are 5, 0, 3, 0. So we can stop here. So this is the final step. So minus Z equal to 12. So that is the 12 from here. So this means Z equal to minus 12. X1 equal to 0. X2 equal to 4. This is the final answer. So X2 value how I can get? X2 value is I got here. So S2 also you can take because basic variables are S2 is 10, S1 is 0. So you apply in the given objective function also you will get the same answer. So what is the few steps I want to remember? So whenever minimization problem, you simply multiply the minus time our objective function. the same constraint, you make the initial simplex table, then you proceed to solve. The same idea, how you are converting the maximize problem, same way. Thank you for watching this video.